Nucleophilic addition-elimination mechanism explained thoroughly. Now, this mechanism can manifest as 3 distinct reactions. However, today in this video, I'm going to be going through the first one, which is hydrolysis using water. Now, the 2 compounds I'm going to be interested in are ethanol chloride and ethanoic anhydride. You could be asked about any acyl chloride or acid anhydride in your exam, but for the sake of not having a million different carbons in my molecules, I use something that only has 2 carbons. Okay, let's react ethanol chloride and water. So the lone pair on the oxygen in the water is attracted to the delta positive carbon connected to the double bonded oxygen. The reason the carbon is delta positively charged is because the oxygen is extremely electronegative and it attracts electron density towards itself. Fair enough. This causes the double bond to the oxygen to break. Fair enough. 2 curly arrows so far. Simple. Now what happens is that the bond to the chlorine breaks. Okay, now we know that the oxygen is bonded to a delta positive carbon, so it itself becomes positively charged, so this causes the bond to the hydrogen to break as well. Okay, and the double bond reforms. Fair enough, there's a lot of things going on now. So the hydrogen reacts with the chlorine to form HCl, which is why when you react with ethanol chloride, you have to do this reaction in a fume cupboard because you'll form corrosive fumes of HCl. However, you don't need a catalyst for this reaction because it's extremely reactive and quick. Okay, so you form ethanoic acid and HCl. Okay, fair enough. Moving on to ethanoic anhydride. Now this reaction, this mechanism is pretty much exactly the same. You form ethanoic acid again, but you don't form toxic fumes of HCl gas. However, you need a catalyst because this reaction is quite slow, so you probably have HCl as the catalyst or something like that. Now, however, the only distinction is that you form an ethanoate ion. So the ethanoate ion reacts with the hydrogen that's been lost from the oxygen to the hydrogen bond, and essentially it gains it to form a carboxylic acid. And you form carboxylic acid anyway. So you form 2 moles of carboxylic acid from 1 ethanoic anhydride, essentially. So that's what happens. That's the only difference. In both reactions, you form carboxylic acid, and the only difference is you don't form HCl. And essentially, you form an ethanoate ion that's attracted to the hydrogen, and that forms a carboxylic acid. You form another carboxylic acid just through the natural mechanism, and that's it. Thank you for watching.